Hey guys, so I know this seems kind of weird. We spent one lesson on taking two polynomials and multiplying them, and now we're going to go backwards and put them back into being polynomials. So we're going to be in 8.5, we're going to deal with factoring. So we're going to factor by grouping, and we're going to kind of talk about, this is basically over the next several lessons, we're going to be talking about how to factor. And we're going to go from the simplest thing we could do to the most complicated thing, okay? And this is kind of the order of how you should approach any problem that asks you to factor, okay? So let's get some definitions in, and then we'll begin in our process. So first word is factoring, which, you know, you've covered that when you were, maybe if I can write that a little better. In 6th grade, we talked about factoring, and it's basically rewriting a polynomial as the product of its factors. So, for example, we would have what we would call, and, well, let's talk about it this way. So, writing a polynomial as the product of its factors. Now, the thing I have to remind you is that sometimes when you factor, a factor can still get factored. So that's going to be something we have to work on, is this factor completely. Okay. Now, if you remember from 6th grade, you were told about, you know, the GCF, pulling that out, and that was the number that was the biggest thing that your values, your terms had in common that you could divide out. So I'm going to teach you a new term, which is like the GCF, but we're going to add another letter, and we're going to add a GCMF. And what that means is not only are we going to look for a numerical, like a coefficient factor that can get pulled out, but we're also going to look for a variable factor, variables, okay? So it's the greatest common monomial factor. Okay, so that's what we're going to be looking for. Okay, now having said that, when you are asked to factor, first and foremost, you're going to look for GCMF. I was looking back at old notes, and oh my goodness, I forgot to look for the GCMF. So here's the problem. Once you factor, you're like, okay, I'm done, and you don't look. But sometimes you wait a second, they're all even. I should be pulling out a 2 or a 4, whatever they have in common. So that's going to be the first thing that we're going to look for, is does your polynomial have a GCMF? Okay. So let's do a quick example of this, and then we're going to launch into, again, let's do this. So when you pull out a GCMF, it's going to give you a remaining polynomial. Okay, and so the second thing is, you have to ask yourself, can you factor the remaining polynomial? Okay, and if the answer is yes, you got to do it. And then you may have to ask, can I factor any remaining polynomial? You have to keep asking that question. Okay, so let's go ahead and just do an example or two, and then we'll get into this, what do I mean by factoring by grouping. Okay, So first example, we have 27y squared, and then plus 18y. Okay, so I'm going to rewrite it again. And I want to start with the coefficients. Is there a coefficient, a number, that divides evenly into 27 and 18? And most of you would probably see a 9 in there. So when I factor out the 9, we get 27 divided by 9 is 3, and we haven't talked about the variables at all. 18 divided by 9 is 2, and we haven't talked about the variables at all. Now 3 and 2, there's nothing more I can pull out other than 1. So what I'm going to do is look for a variable that they have in common. So pay attention to this. They both have y's, but the most I can pull out is 1y, because I couldn't pull 2 y's out of that second guy, right? Because it's only a y, not a y squared. So that's the other thing you have to watch out for. So we do 3y squared divided by y is just 3y, and then plus 2y divided by y is just 2. So when I write my answer, it's going to be the product of the GCMF and the remaining polynomial. So notice that when I'm using this factor ladder method, the GCMF is on the left and the remaining polynomial is on the bottom. Okay. Now another thing to notice, two terms here, it's a binomial, and we have two terms here, or binomial. So the number of terms in your remaining polynomial should not be different than what you had originally. All right, let's try another one. And let's see, we've got negative 4a squared b minus 8ab squared, and then plus 2ab. So always start by writing down the original problem. Super important, okay? Always, 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 okay? And then always, always, always check your remaining polynomial to see if it can be factored more. So I'm going to rewrite it a second time. I can reference and make sure that I'm copying it down correctly. So then I'm going to look at the coefficients first. So I have a 4, an 8, and a 2. So at most I could do is pull out a 2. Now the other thing I am going to talk to you about is that if your polynomial starts with a negative like this one does, then I would be pulling out a negative. So I'm going to show you that. Now if you don't pull it out in the beginning, most people pull it out at the end. Just saying. Okay. So I'm going to pull out a negative 2. And then we have negative 4 divided by negative 2 is a positive 2, and then I haven't done anything with variables. Negative 8 divided by negative 2 is a positive 4, and again I haven't done anything with the variables. A positive 2 divided by a negative 2 is going to give me a negative 1, and then I just write the variables. So I don't have any negatives, okay? Now I'm going to take my variables one at a time, because this is kind of new to me. And let's see, I have an a squared, an a, and an a. So I can at least pull out an a. What does that give me behind? 2ab plus 4. The a gets divided out, and that leaves a b squared, minus the a gets divided out, and there's a b. So now I'm going to look at my b's and see if there's anything that I can factor out. Let's see, I have b squared, and b. Okay, so that means I can pull out a b. So 2ab divided by b is just going to give me a 2a. And then plus 4b squared divided by b is just going to give me a 4b. And then minus, and b divided by itself is 1. Now this is the most common mistake kids have. They think, oh, it cancels out. But the problem is it doesn't. It divides out. That still leaves a term there. So I had 3 terms to begin with in my polynomial. I need to have 3 terms to end with in my remaining polynomial. So I'm going to go ahead and multiply the guys on the left, and I get negative 2ab. That's going to be my GCMF. and then the remaining polynomial is 2a plus 4b minus 1. Now again, let me just explain to you why we learned how to multiply, because we can always multiply our answer to double check that we get the same beginning problem. So you have a built-in check system on this. All right, so let's get into the factoring by grouping. So this is when you have generally 4 terms, and you got to figure out how to group them 2 by 2. Okay, and then we look for a little magic that happens. So let's write down factoring by grouping. Now again, this is the kind of easiest way of, easiest part of factoring is GCMFs, and basically all we're doing when we factor by grouping is looking for GCMFs, but twice in a problem, okay? So you have to have 4 more terms. In the polynomial. But they must group into 2 groups. That each have a GCMF. Now, they may not have the same GCMF. Most likely they won't. And then dot 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 magic happens. Okay, and you're like, well, that's very mathematical, Miss Rosner. Yeah, you're right. All right, so in general, let's say we have AX plus BX plus AY plus BY. Now, in my experience, generally speaking, there's not a lot of times when I have to rearrange what I have. I can usually look and say, hey, the first 2 terms have an X in common, the second 2 terms have a Y in common. So that's often how I group them. The first 2 and the second 2. Now, the only thing you have to watch out for are your signs, which is something we always have to watch out for. So we have an X in common with the first pair, and the second pair have a Y in common. So this is what it looks like. We factor out the X. That's going to leave behind A plus B. And then it says plus, and then we're going to factor out the Y. And here comes the magic. We have A plus B. So here's the deal. We still can factor more. Why? Because both of our terms have an A plus B in common. So we're going to factor out the A plus B. So this gives me, oh sorry, that's not supposed to be there, the quantity A plus B. And then what's left are the guys that were the coefficients. They're going to form their own binomial. Okay? And that would be the answer. Okay? So, generally speaking, when we do factoring by grouping, I'm going to go back up here and add a note. Generally, the solution is a binomial binomial times a binomial. Now, you could have a GCMF that they all had in common in the beginning, and you pull that out, and then you could have a binomial that can get factored further, which will happen later on, and then that's going to be, you're going to keep getting more terms. Okay, so first and foremost, when we're going to do these problems, we're going to remember to look for GCMF first. Always. Now I was kind of glib on our little example problem because I noticed straight away that they didn't all four have the same thing in common. So this is the thing we have to watch out for. Okay. Now, sometimes we're going to have weird looking variables. Sometimes we're going to have the same variable with different exponents. So if we can, we will try to put things in descending degree order. If you remember that from the answers on 8283. So let's say we have this guy. So let's see what we got going on. We have 4QR plus 8R. And then plus 3Q plus 6. So I'm looking for the first two have a 4 in common, the second two have a 3 in common, but they don't all have something in common. So there's no GCMF in this one. So then I'm going to look to see if the first two have a common factor, and I see, yeah, they have a coefficient of 4 in common, and they have an R. So I'm going to factor out a 4 and an R. On the second one, I noticed that they have a positive 3. Now, why is it positive? Because that's what's in front of the 3 in the original polynomial. Okay, so let's see what we get. We get 4R, and then we have 4QR divided by 4R, that leaves the Q, plus 8 divided by 4 is 2, and R divided by R is 1, so I just get Q plus 2. Then I have a plus 3, and it's really important you write that operation, because that's going to play a role in the answer. Now 3Q divided by 3 is Q, and then it says plus, and then 6 divided by 3 is 2. So look at that, our magic happens. So we're actually going to factor out the binomial Q plus 2. So that's going to give us Q plus 2 times, and this is where it gets a little funky, we're going to pull out those coefficients and make their own binomial. So we have 4R plus 3. So I'm going to double check to see if there's anything more I can pull out of either of these, and since I have different variables, that's nothing there, and no coefficients in any binomial that repeats. All right, so I'm good. That's it. There is my final answer. Okay, let's try another one. Let's do Rn plus 5n minus R minus 5. Okay, so the first two definitely have an n in common, and then we have the other two have a 1 in common, so it should work. Now, the issue that we run into this problem is this guy right here. So we're going to need to make sure that we must factor out the negative. Okay. All right, so looking for our grouping, these two have an n in common, and I'm going to show you how I factor this out. I'm going to take out the negative 1, okay? So I'm dealing with that negative. You always have to pay attention to that. So we get n, and then we have Rn divided by n is R, then it says plus, and 5n divided by n is 5. Next, we're going to factor out a negative 1. So negative R divided by negative 1 is just a positive R, and negative 5 divided by a negative 1 is just going to get a positive 5. So our miracle occurs, the magic happens, so we're going to factor out the binomial that they have in common. So yeah, factoring sometimes is a GCMF, and sometimes it could be a binomial. So then we get the quantity 5 plus R, and then we're going to grab the two coefficients. that's going to put n and then minus 1. And then I double check to see if I overlooked anything. I don't see any coefficients that are the same, no variables. So that's it. I'm done with this problem. All right, so we're going to go, and again, every problem I have has got a slightly different issue with it. So we've got 2 more to do and we'll be done. Oops, we're on number 3. So this one, we have 3p minus 2p squared minus 18p plus 27. So in this one, I have only the same variable. I don't have 2 different variables. So this is a situation where I'm going to rewrite in descending degree order. That means from largest to smallest, descending degree order. So largest to smallest exponent. So that means I'm going to put the squared, oh, I think I didn't write that right. No, I did. So I'm going to put a negative 2p squared. Oh. Sorry about that. I'm making bread and my alarm went off to go down and tend to the dough. So here we go. Let me go back again. So we had negative 2p, and I'll be honest with you. If you can avoid it, try not to put a negative in the middle because it's pulling out that negative that sometimes throws people off, okay? I'm not going to do it, but I'm just going to suggest that, and I'll show it another time, okay? All right, so notice if I just rearrange the first 2 terms, I'd have negative 2p. So maybe I'll show it to you. And we get plus 3p, and then minus 18p, and then plus 27. Okay? Now we're going to look for something that each pair have in common. So again, I see that negative out in front, so I'm going to pull out a negative, and I'm going to pull out a p. Okay? So that's going to look kind of strange. That's okay. And then for the other guy, I'll show you how to handle it. There's a negative out in front, so I'm going to pull out a negative. And let's see, they have a 9 in common. Okay, so here we go. So on the first one, we have a negative p. And then we're going to divide everything in that pair by negative p. So negative 2 divided by negative 1 is 2. P squared divided by p is p. And then 3 divided by a negative 1 is a negative 3, and p divided by p is 1. So notice what happened. Now my sign changed, okay? All right, next guy. I'm going to pull out a negative 9. Isn't that funny? P and 9, if we flip them around, look like each other. Weird things I observe. So negative divided by negative is a positive. 18 divided by 9 is 2, and then there's a p. And then 27 divided by 9 is a negative 3. Okay? And miracle occurs, so we're going to factor out that common binomial, 2p minus 3. 2p minus 3. Now, sometimes what ends up happening is people end up having to rearrange terms by pulling out a negative. And so that kind of creates a brand new thing, so I'll kind of show that to you in the next problem. So out is the 2p minus 3, and then the remaining polynomial is negative p minus 9. Now I got to be honest with you. Here's the issue. We tend not to write this type of answer with the negative in the first term. For whatever reason, we don't like looking at a negative in the first term. So if you look at your second polynomial, the first term has a negative. So I'm going to pull a negative 1 out. So that's going to give me negative 1. And then I still have the 2p minus 3. And then that's going to leave me behind a positive p plus a 9. Okay, now that's one way to write the answer. In fact, well, without the negative, so negative times the quantity 2p minus 3 p plus 9. And then sometimes what people will do is they'll distribute that negative to both terms. That makes the 2p negative and the 3 positive. So they'll switch those terms around so that the first thing you would see would be a positive number. So all sorts of weird things that people do. Okay. I'm happy with the first answer. I would not be happy with the negative p minus 9. So this would be the first answer. That one I'd be happy with. This one would be fine too. But I would not put the answer like that. Okay? All right, last question, and then we have the weirdo thing that happens. 2CD. So this one goes back like the first two where I don't have the same variable, I don't have any exponents, so I'm just going to try to group them and see what I come up with. And I'm looking for GCMF, and 3 of them have an even coefficient, the other one doesn't. 2 of them have a C, 2 of them have a D, so no. So on this one, what I see they have in common is a C. On the second one, what I see they have in common is a positive 4. So let's go ahead and factor. So we have C times the quantity. C divided by itself is 1, minus 2CD divided by C is 2D. All right, next one we're going to pull out a positive 4. So 8D divided by 4 is 2D, and then negative 4 divided by positive 4 is a negative 1. Okay. So this is a situation where you're going, the magic didn't happen. But can we manipulate the situation to make the magic happen? The answer is yes, we can. How? We're going to factor out a negative 1. That negative 1 is going to multiply with that positive 4. So now what we have is C times the quantity 1 minus 2D minus 4. So what happens, oops, that was the wrong way. Bink, there we go. 2D divided by negative 1 is going to be a negative 2D. So I'm going to put them over here. And then negative 1 divided by negative 1 is a positive 1. So I'm going to put them in the front. And then the magic happens. So that's, we can manipulate by swapping around the order of our terms if we divide out a negative number. So we're going to factor out the 1 minus 2D from each of these. Bummer, none of these had GCMFs, but not necessarily the case when you get to your homework, that's for sure. So we have 1 minus 2D, and that's going to leave behind, let's see, a C minus a 4. And that looks like a pretty good answer right there. Okay, all right, good luck, guys. We'll talk about this in class. Bye now.